Buenos días a todos.
Good morning
Quería
to
empezar
everyone.
con la pregunta que aparece en pantalla.
I would like to start with a question that you can see on the screen. Ultrasound and enzyme. Is it a perfect combination? Everything seems to point at this being a perfect combination, but how to do it? We're going to solve today this riddle together with my colleague Belen Bautista. So here you can see an image that you know, which is a vegetal cell composed mainly by the cell wall, the cytoplasm, the nucleum or nucleus. But what interests us is the components that are in the plastid, those vesicles that are in the cytoplasm that we need to break. Breaking, obviously, first the cell wall to produce their extraction or to extract them and thus release the polyphenolic compounds, the polysaccharide compounds that are in the wall, and even aromas. How has this extraction been made traditionally? The enologist there's some problem with the pointer. What is the pointer? There, okay, thank you. So, traditionally, the enologist has been using a series of resources, such as the ones you see here, to improve or lengthen the maceration times, to use high fermentation temperatures or thermal treatment on the grape. And of course, the case that we are going to explain today is the application or the use of enzymes. Here you can see a cell wall that is made up by its medium layer with composed by chains of galacturonic acid, galactose, the primary wall made by cellulose and other compounds, and the secondary wall that does not always appear in the vegetable cell where we find lignin or cellulose. It is very important to bear in mind the pectin chains, because it is a kind of cement both in the medium part and in the primary wall, which avoids the release of these compounds, phenolic compounds mainly, to the outer part of the cell. Traditionally, we have been using pectinase, this pool of enzymatic activities, the polygalacturunose pectin liase and pectin methyl esterase. The pectin liase breaks between 2 and 3 galacturonic acids, breaking thus the chain and releasing the phenyl compounds. And this chain is methylated. Therefore, if there is no methyl group, then this pectin chain is not going to be broken. Then we also have polygalacturunose, which is doing the same job as the pectin liase whenever this chain is demethylated first. And that's why pectin methyl esterase needs to work first. So the combination of these two enzymatic activities is essential to break the cell wall. Belen will give you more data on these enzymes, but I'm going to present them in the study that is going to be explained by Belen. We've chosen Enosim Lux and Enosim Vintage. The first one having a high pectin liase activity, which is essential to break the cell wall. And however, Enosim Vintage has also pectin liase activity, a bit less than Lux, but it has cellulase and hemicellulase activity. And therefore, we are going to study, using ultrasound, which of these enzymes is better to extract compounds. And we move from traditional techniques to new techniques, emerging techniques. Antonio Morata was explaining this morning some emerging techniques, non-invasive techniques that, for example, ultrasound. Every ultrasound is useful to extract these compounds? No. One essential requirement is to use ultrasounds with high power and low frequency. This is very well studied by Agrovin. What does ultrasound do? It reduces more in less time. Ultrasound needs to be seen not by us, not as something weird or volatile that cannot be applied easily. I show you this slide so that you can check that, or you can see that ultrasound has been used on the medical field and the agri-food field for decades. In medicine, it's used for the screening, the diagnosis, and therapeutical purposes. And in the food industry, it is useful to determine the maturity and texture of fruits, but also to cut foods, such as cheeses, for example. And therefore, it is a safe technique that has been validated in other sectors. Agrovin has been studying it in depth and apply it to our sector. It is so safe, this technique, that we defended it before the OIV with the technical group in OIV Spain, and in 2019 through the resolution 616/2019, this technology was approved with the title of Treatment of Crushed Grapes with Ultrasound to Favor Extraction. So it's not only used to extract polyphenolic compounds, but also to extract other compounds such as polysaccharides that can have great enological or aromatic interest. But I'm speaking about ultrasound, but how does ultrasound work to favor extractions? Well, through a chemical process, physical process called cavitation. Cavitation is the production of small bubbles that implode and release energy by producing the erosion of the skin cells that breaks the cell wall and therefore allows for the extraction of compounds to the outer side of the cell. This is the basis for cavitation and is the basis for ultrasound. As an image worth more than 1,000 words, you see skin, a skin or a grape skin cell, where you can detect the cell wall, the membrane. With number 2, you can see the plastids. So you can see this is a full cell. We call it the witness cell. However, by applying the ultrasound technique, we see that in the microscope, and we see a total collapse of the cell structure. Here, in the cytoplasm, you cannot observe the differentiation between a well-formed plastid. Everything is mixed up. Here you see small canals through the cell wall that allow the passage of the cytoplasmic content to the outer side of the cell. And this is how ultrasound techniques work. As you can imagine, this has not been an easy way. We are researching on this technology since 2014. Well, since 2012, in fact, but we published our first work in 2014, up to the moment that we obtained a machine that can work on an industrial level. And the support that Agrovin got was from the European Commission. The Horizon 2020 project funded our project. And of course, the European Commission is helping us to patent this system. Normally, when we develop something, we protect it, and ultrasound, of course, is patented. This is an equipment that is protected from California to New Zealand, as you can see here, going through Argentina, Chile, Europe, Africa, etc. This is the equipment. You cannot see a lot, I know, the ultra-wine Perseus, but I would like to explain about the treatment unit, which is the cavitation cell, which is a tube in stainless steel, where these parts are coupled, and they transform the electrical energy received by the transformer into mechanical energy, which is producing cavitation in itself, with the goal of, here I'm showing a little example where you can see the glass of wine. That one is not made with the ultrasound technology, and you can see that the color in that glass is a bit more pinkish than the other glass on the left-hand side that you can see in a much deeper color. This is one of the applications of ultrasound. There are different models available. One 6-kilowatt equipment has been coupled with different working flows, such as 3,000 kilograms per hour. But normally we have been working with lower flows. But Agrovin has these models, and we are constructors, and we can manufacture according to the requirements of the client. Normally we work on red wines, but we have been carrying out and conducting several works in our cellars, in our wineries, with white wines, with real productions of 50 or 60,000 kilos, both in the case of red wine grapes and white wine grapes. We were working with Sauvignon Blanc mainly, and I'm going to use the numbers so as not to use the pointer. The grape is received in our cellar or winery. It is crushed, and it is destemmed, number 2. Number 3 is the pump. It is taken to the pump. Number 4 is the ultra-wine Perseus. The press with number 5 presses those grapes, and then we ferment them in the fermentation tank, number 6. So we extract the compounds from the skins to the aroma compounds. With Perseus, we can skip this step. In the case of white wine. In the case of red wine, well, this system is practically the same. We receive the grapes, we crush them, we destem them, we take them to the pump, we take them to the ultra-wine Perseus equipment, and then we macerate. This is the main difference. There is a maceration phase. How long? Well, depending on the degree of maturity and the variety, in 72 hours we can stop the maceration phase. Surprisingly enough, when the winemaker works with the system, he or she prefers to lengthen this maceration once this grape mass has been treated. Normally, they prefer to leave maceration up to the end of the fermentation so as to extract much more and in a much better way. Ultrasound has different applications, and it can extract different compounds, such as aromatic compounds, polysaccharides, and phenolic compounds. And in the upper part of the slide, you can see that it produces an effective treatment of the grapes of the climate change, meaning that those grapes that are unbalanced in their phenolic and technological maturities, those compounds that are giving color and sugar, through ultrasound we can treat those grapes a bit earlier, if necessary, so as to produce an effective extraction of those polyphenols, so that we won't have high alcohol degree wine with right color and an adequate or suitable polyphenol concentration and the right maturity degree. The tests were done to test all the requirements that determine the use of ultrasounds, the main one being variety. We have been working in Carmenere from Chile, the Sauvignon Blanc from New Zealand. In Europe, we have been working with all types of varieties to precisely establish a work protocol focusing on making every one of the varieties in a very efficient way. We have generated thousands of data. And here, I think you've been able to read these data for several years. It was not only on a national, but also on an international level, such as the Foods Journal or the Foods and Technology Journal, where this recent study was published on the synergic use of enzymes and ultrasound that Belen is going to explain about. So I'm going to finish by this, and I'm going to give the floor to Mrs. Belen